So now I'm going to do a convection demo that's going to represent a convergent plate boundary. What I've done here is I've set my convection tubes up, filled them up with water again. I've put in the edges of the convection tubes on top of the heat plate. Again, the reason for this is to manipulate the temperature within the tube. The water over top of the heat source is going to get warmer and less dense and rise. The area away from the heat source is relatively cooler. It's going to be more dense and sink. So you're going to get circulation within here. When I put the food dye in, the tube on the right here, okay, the food dye should automatically go to the left. When I put the food dye into the left tube, it should go to the right. And this, again, this is going to signify a convergent plate boundary. So you can see immediately the two tubes, the food dye is going to go immediately to the cooler side of the tube. See, now the food dye is coming along the bottom. It's going to come to the warmth and then come right back up, rise up where the water is going to be warmest. So the food dye is coming down and around, coming over to the warmth. Warm water rises and you end up getting that circulation. This is convection. Now the one on the right is a little bit slower, but that's okay. You're still getting the good circulation. You still see how that food dye is working its way up the tube now. So what's nice about these demonstrations here is it shows you where the area where it's a little bit cooler, it sinks. The area that's a little bit warmer rises. Sinking water is more dense, rising water is less dense. We're just going to wait for this one to kind of make its way all the way up. Good, we got our circulation. So this tube on the right side went in a counterclockwise direction, while the tube on the left side went in a clockwise direction.